Hello, everyone. Welcome to our session, which is modeling data in document databases. My name is David McAgon, and I'm an Azure architect in the developer experience team.
Hey, and I'm Ryan Croker. I'm a program manager on the Azure Document DB team. We're going to spend some time in this session, and we're going to go over modeling data for document databases. Now, we've all done things in relational databases for many years, and we've become really good at doing that. And now when we come across the document databases, we have to retrain our brain. We have to think slightly differently when we do this. Otherwise, we may run into some challenges. And we'll talk about some of those challenges, about modeling challenges, and we'll also take a look at a couple of real-world case studies. So some of the modeling challenges, that people run into are here on the slide, and we see this in real applications dealing with customers. And we'll go through a couple of these and show you some tips and tricks and patterns to overcome these kinds of challenges. And then we'll take a look at a couple of real-world use cases that people may have struggled with.
All right, so let's talk about document modeling for a little bit. Now, if you think in the world of relational data, right, you always had to model first. You thought about your tables and you thought about what went in it and you built your schema. So just because we're in a document database, that doesn't mean we don't model. We're still modeling, and it's just as important as in a relational database. It's a little bit different where the relational data engine is typically enforcing your schema, where in a document database engine, typically it's the developer that's enforcing that schema. So, and as you build your models, it's usually built from some use case that you're working on and driven from your code on down to the database. And as we'll see, some of these models can and do change. So you could always evolve these models as you go.
Oh yeah, and to set the scene, to kind of set the context of what we're talking about and how fundamentally different the approaches are, I'm going to paint a scenario quickly. And there are two extreme scenarios, one on either end of the spectrum, but it should give a good idea of the difference between the two approaches. So let's say I'm building an application that deals with motor vehicles. I might be selling motor vehicles, second-hand motor vehicles, or whatever the case may be, right? And I want to display a motor vehicle on the screen. What I may typically do in a relational database is I may use some kind of ORM or some kind of mapping tool or some kind of middleware that takes my app the data that my app is presenting on the screen and changes the format and then stores it in the database separately. So in a relational database, I may actually take my motor vehicle and break it up into its component parts and store each one of those component parts in their own kind of table. I may store all wheels together and all engine blocks together, and you get the idea, right? Very extreme, and you probably wouldn't model a database quite as extreme as the picture, but you get the idea. And then when you want to display the vehicle again on the page, you write a bunch of code either in the database or in this middle tier or in your application to take all of these parts, reassemble it back to a motor vehicle, and then present the motor vehicle on the page, right? The other side of the spectrum in a document database is this notion of come as you are, right? So you have a motor vehicle and you send that over the wire as it is, and you persist that whole motor vehicle as a motor vehicle object in the database. Right? And when you want to display that motor vehicle on the page, you do a query for the motor vehicle, you bring it down over the page, over the wire, and you display it on the page. So come as you are, right? And those are the two different kind of extremes. And I hope that illustrates the kind of point that I'm trying to get. So if we take a look at a more realistic data modeling example, we've all seen the kind of data model that's up on the screen, where we have a person, and a person has some contact details, a contact detail has a type, and we split these up into separate tables, right? And we use foreign keys to kind of, break this up and reassemble the object. And that's what it would look like in a relational world. Now, a document world, we take a document called person, and we have attributes, and on that, we may actually go and embed in an address, a contact detail, or multiple contact details. And this is what the same thing would look like in a JSON document.
Yep. So this brings us to our first modeling challenge, which is related data. And what is the question we ask? To embed or to reference? So it's not always clear which one you're going to choose. And one of the extreme examples there that Ryan showed was an entire car in one giant embedded document. And the tendency for working with document databases is it really certainly looks easy to embed data. So what we're going to do is look at the two options of embedding and referencing and give you some signals that might hint which one you should use. So here we have just one example of a document. It's a It's a session, like a talk session that we're doing right now, document modeling, and it has an array of speakers which is embedded in that document. Now we could also take the reference approach, where now we have this document for the session and we have separate documents for the speaker. So the question is, how would we choose?
Great. So David brought up the thing of sometimes we embed and sometimes we reference, and how do we choose? And that really is the question of kind of, when should I do this? When should I do that? So let's dive into these in a little bit more detail and take a look at embedding and those signals that will kind of guide you towards embedding. And the first signal we want to kind of take a look at is this notion of things that are queried together, right? Queried, updated, operated on together, right? So imagine a world where I go into a library and I walk into the library and I'm looking for a book, right? And I go and look up and I find that the table of contents are in this rack over here, the chapters are in that rack over there, the covers of the book are in a different rack. And I go through the library and I extract out the pieces that I want, and I kind of go to this person in the library and he reassembles my book for me. I then take my book home, I read it, draw little pretty squiggles in it, and everything's good. And when I'm finished with the book, I bring it back to the library and I take it to a person and he rips the book apart and goes and puts the covers back where they were and the table of contents where they were and the chapters where they were, right? That's completely ludicrous, and we don't work in a world like that, so why should we have data that we model like that, right? So to me, a logical kind of approach says, hey, if I'm looking for a book, I want its table of contents, its chapters, its covers, everything about that book. I want to walk into the library, grab it as one piece, and walk out with it. And when I bring it back, I want to put it back on the shelf as it is. So I may take those objects, and instead of storing them in individual tables and then having this man kind of assemble my book for me every time, I may actually just want to store it like that. And now what I'll do is in the library, I'll have multiple of these objects stored, right? So to show you an example of how that may look in JSON, here's a book that's been kind of modeled, and you'll see there's the book object, and embedded on that book object is now the covers, the chapters, but it's one object that I can actually retrieve from the database and persist back to the database. So there's an example of things that are queried together and operated on together should be stored together, and therefore embedding is a really good kind of use case for this.
Sure. All right, so the next signal that we want to talk about is dependencies. So if you could imagine an order that we're placing, let's say Ryan's placing an order for all of his books. So there's the order and then the line items in the order. Those are dependent on each other. I wouldn't exactly want to query a single line item. I would query the order with all the line items. So this might be how it looks in JSON. So I have the order, and then I have an array of lines within that order. So again, I'm always querying this together. So it makes sense to embed the lines within the actual document.
Right, absolutely. Another signal that we can look at is this notion of relationships, right? So this data is related, and you get the notion of a one-to-one relationship. So for every one book, there is exactly one of the other element, right? So an example here would be if we look at a person document modeled in JSON, right? The person has some attributes, and then the person has a sub-document or a sub-object that's related to this person, but it's only ever a one-to-one match, as in this case, the profile information. And there it's really, makes perfect sense to take that related document or that sub-document and embed it on the actual parent.
Yep. So another signal we have is volatility. So you want to group data with similar volatility, how often it's changing. So let's take a look at another person document where now this person has an email, but they also have a group of social IDs. They're going and registering for different sites, in this case TwitChat and Instabook. So maybe they have several others, but if you think about volatility of it, how often does your email change? Really not often at all. Same thing with your name, and maybe you register every now and then for a social site, but it's not that often. So this data changes at about the same pace.
Great. So one more signal that we want to kind of take a look at is again about related data and embedding these sub-documents onto the parent document. And in this case, instead of a one-to-one relationship, we're going to talk about a one-to-few. And what I mean by one-to-few is an example here would be a session, such as this one, that we've got tags on, right? And a session has a finite amount of tags. I mean, we don't know exactly how many tags it's going to have, but it's a finite amount of tags. All right, I'm not going to have millions and millions and millions of tags on a session. So for this to actually change the model slightly, we can actually take those tags and we can actually embed them on the document. And there is no problem at all with this because that's a bounded array, right? And it's not going to grow to silly size, and we're not going to end up working with these monster large documents. So a query for this, if I'm looking for all tasks related to build, I could just run a simple query like this that says, hey, where tags equals build, and I get back all a list of my tasks for build.
Sure. So we have seen this set of signals that says, oh, maybe I'll embed this data. And typically when you embed the data, that leads to better read performance because you're typically making only one round trip to the database server to retrieve all related data.
Cool. So we've taken a look at embedding, right? And that's where a lot of people kind of get to with document databases. But sometimes we don't go any further, right? Because we've been told, no, it's a document database, so you've got to embed, you've got to embed, you've got to embed. But we're here to say that sometimes referencing is actually better. So let's take a look at a couple of times when referencing is actually better. So one of them is, I talked about bounded arrays, right? Where tags on a session, there's a finite number of tags. Well, what about unbounded, right? So let's take a look at this talk again. And now we've got a comments array. Now, depending on how many people watch the session and how many people want to post comments, there could be millions of comments, right? And we don't know. There could be tens of millions, hundreds of millions of comments. There is no bound to how big comments can kind of grow. The problem with this is that as these get bigger and bigger and bigger, the document gets bigger and bigger and bigger, and it becomes slower and slower and slower to work with this kind of document. So instead of embedding in this case, we want to take those comments and explode them out into individual documents that reference the main document. So in this case, when people add comments, we don't have to keep changing the actual session. All we do is we just keep inserting new comment documents.
Yep. So another signal that says maybe we reference is many-to-many relationships. So what do we mean by that? Well, here we have some speakers. So we have Ryan and David as speakers, and then we have some sessions that we're giving talks on. So it's entirely possible that one speaker will have multiple sessions to give talks at. One session will have multiple speakers, so you have that many-to-many relationship, and that's what we're showing in the middle. Maybe that's not exactly how you'd typically model it in a document database. Maybe it looks familiar. That's because that's typically how you would join data in a relational table. So let's take a look at a slightly different way of doing this in a document. So here's an example where we have, on the left side, we have a speaker with embedded session IDs. And then on the right side, we're showing a session with embedded speaker IDs. So now, there's no real hard and fast rule which way you want to build this relationship. It's entirely possible that your application might start at the session level and then drill down and show you the speakers. Likewise, you might start at the speaker level and then show which sessions that speaker is talking at. And here's a very simple query. If we take a look at it, what are we doing? We're looking at for speakers for a given for a given session ID, right? This is going to return all of the speakers for that session. And likewise, in this query, for a given speaker, what sessions are they presenting? So it's very simple to query either way.
Cool. So another signal that you can use to help guide you towards referencing instead of embedding is when data changes with different volatility, right? So David spoke about similar volatility as being good for embedding. But if we take a look at the following kind of document, now we have a session, again, this talk, but we have some data that's fairly static, right? And then we have other data that changes very, very often. Well, we hope very often, like likes, hearts, the number of times the session's been viewed, etc. So now we have data that changes at a very different velocity inside one document. So it may actually be better to take this volatile data and explode it out into its own separate document. So now I have the core session on its own that can stay, that changes very infrequently, and then have a very small document that changes frequently. And now when I add a like or a comment or a view count or whatever the case may be, it's a very small document that I have to keep updating.
Sure. So another signal that might say we want to reference is when there's a a key entity that's used by many others. So in this case, we keep talking about these talks. Well, if we actually went to the facility where the build conference is at, there's various rooms, and maybe this session is in room 201, has a capacity of 200 people, and there's some recording equipment that's available. Now, let's say that there's 50 different sessions in that room, and then the recording equipment gets moved to another room. So the last thing you want to do is update 50 different documents just setting the recording to false.
Right.
So this is an example of Signal where we want to take this data and pull it out into its own document. So now we have a separate room document, and now it's easy to change that. And we simply reference the room ID in the original talk document.
Very cool. Okay. So as you can see, even when working with document databases, you don't have to embed all of the time. Sometimes it's okay to reference, and here we've spent the last couple of minutes kind of looking at when is it probably better to reference than embed. And we find that referencing generally will provide a more optimal write path because you have smaller documents that you have to go and kind of write. But it may actually result in you having to do more reads against the database. And we'll show you some techniques a little bit later to address this very specific point.
Sure. Now, it turns out we can combine referencing and embedding, right? There's no rule that says I'm always going to embed, always reference. And
rules?
So let's take a look at a real-world product. Now, we actually don't know how this site is implemented, right? This is Microsoft Store. We just grabbed a snapshot of one product page. But if we were to take some guesses, there's probably some master document that has general information about the product. Maybe it has some cached or pre-computed information about the number of reviews. And if we were to drill down on the reviews, maybe it has the rating snapshot pre-computed. It has the most helpful voted review. So we see a lot of interesting things in this one example. So we talked about how things are embedded. Well, maybe that snapshot on the front page is embedded in the main document, because when you search for that product and you pull it up, you want to see the images and you want to see a quick snapshot of the current average score. Then you drill down and you want to see a quick snapshot of how the stars break down and what's the most valuable review.
And you were talking about pre-computed because you wouldn't want your database engine to have to recompute this every single time someone loads up the product details page, right?
Right. That would be quite a load on the server if everybody is just viewing and surfing different products without actually drilling down.
Yep.
So in this case, we might have some partial content embedded where we have a snippet of a review and then a link to the full review, right? And then think about volatility. We just got done talking about volatility. The product itself, that'll rarely change. Maybe the price every now and then, but the number of stars, that changes often. And the most helpful, favorable review, that'll change at, again, a different volatility. So maybe this is how our core document looks, where we have the product, the name, the price, maybe some links to images, and an embedded object with the review summary. But notice that no other information is in there. We didn't put that helpful review. We didn't put any of the other computed information. So here's a simple query that pulls the document back. Again, there's not much in the product other than the core product information. This might be the query we run to get the rating summary, which just returns how many, the count of each stars. And finally, we do a query that pulls back the most helpful review. So again, there's just a snippet, and then the full review is linked to. So this is an example of a mixture of embedding and referencing.
Okay. So David's just talked about the combination of embedding and referencing and how there are no hard and fast rules, right? I want to spend a little bit and talk about normalization and denormalization and how there is also no hard and fast rule. So if we take a look at a normalized data model with references may look like this. You know, I may have a session and then an array of just speaker IDs, right? And we're used to that because normally in a relational database, we'd have a foreign key ID and we'd be pointing that off to the primary table, right? But what this means is when I retrieve a session, I'm going to get back an array of IDs, okay? And in order to show anything useful about the session or about the speaker for that session, I'm going to have to go do a subsequent query against the database to then go and retrieve the information for that speaker. Well, what happens if I just want to show every time I load a session, like the product, all right? Every time I load a session, I want to show just the speaker's first name, and maybe some other information about that speaker. Am I going to go and do this kind of double load every single time I load a session, right? Maybe I can make a small change to my data model, and I could do, I could take some information that's important in the context of a session and denormalize that and put it on the session record. Only some, not the whole speaker record, right? If I want the whole speaker record, like David was saying, I can then drill into it and then go and load the full speaker record. So here I've done something like, I've only got the speaker's first name, right? And I've only got a part of his profile. Because when I show the session and I show the name of the speaker, I only want to show a small snippet just to whet your appetite, right? And then when the person wants to see the whole speaker, they could click on the speaker, and then we go and find the speaker ID and go load the full speaker document. So here's a case where I've actually denormalized some of the information that's important for this particular use case onto that document.
All right.
So if we take a look at, normalized versus denormalized, normalizing your data may save some space, right? And back in the day, saving space was really important because storage was really, really expensive. Today, when you're paying cents per gigabyte for storage, it's not that important anymore to be, very specific on how much storage space you save. So sure, you can duplicate a few bytes here and there, right? We find that it provides faster write speed. Same as that, the notion of being able to write smaller kind of documents because I've denormalized it, I can then go make more finite grained kind of updates. If we take a look at denormalized is the other way around, okay? And we find that provides a better read speed, as you saw in my session with some info from the speaker, because now I only have to go read one document and I've got all the information that I need for the speaker at the time. I don't have to go make multiple reads. So you can see there are some clear trade-offs. And you really need to think about your application and how your application is using data, how it's presenting data, and make some of these kind of decisions or use some of these signals to help you.
So let's go on to our next challenge, homogeneous versus heterogeneous data. And what does that mean? So in the relational world, when we had things like speaker and session and room, you would go and build tables for each of these. And you could still do this in the document world. We call these collections. And so you can have a speaker collection, session collection, room collection. Not a problem. That works fine. However, you have to think about what kind of impact this has. For instance, on billing, maybe you pay per collection. Or transactions, it could be that the scope of queries or stored procedures is bound by a given collection. So there are things to consider when running queries, and you might want to actually query more than one type of data at the same time. So we'll see an example of that. So let's look at the heterogeneous approach. So here we have a speaker document and a session document. Now we can store these in the same collection. Of course, that trips us up a little bit if, let's say, they both had name and we just wanted to pull out, something.name, but we only want the speaker name. So now we introduced, as a little trick, a type property. So that's indexed on type, so we could say where type equals speaker or type equals session, and that's a great way to filter a given data type or document type. And if we wanted to do a query, for instance, so this query here, we're looking, as long as the type equals session, can you please bring back all the sessions in the database, which is exactly what this query does. Now, taking that one step further, this query here is simply searching for a given room. So now if we take a look at the data, we pulled back a room document and we pulled back a session document that is in that room. And then if we go one step further, now we're doing a query where we're looking for, if we take a look at this, something where the array of session IDs contains session 1. So now we have the room with session 1, we have a speaker who's assigned a talk with session 1, and a session called session 1.
That's pretty cool. So in one single query, I can now bring back 3 different data types as opposed to doing 3 separate queries to my database.
Right. If they were in separate collections, we would have to do 3 separate queries.
Absolutely.
Yep.
Cool. All right. So we've taken a look at some of the challenges and some patterns of kind of how to guide you and help you work around some of those challenges. Let's take a look at a few common use cases that we see out there in the wild. So the first one I want to spend a few minutes on is hierarchical trees, right? So imagine that I have some org chart that I'm busy modeling or some hierarchical structure, okay? And in this case, I have Jill, and Jill has a number of people working for her. I could probably model this something like that, okay, where I have discrete documents per person, and in this case I'm really interested in the person's name and who that person's manager is, okay? So I could, based on that model, I can go write a query that says, hey, given the person Susan, find me who the manager is. And in this case, Susan's manager is Jill. I can also flip the query around the other way, and I can say, hey, where the person, given a particular manager, in this case Jill, tell me who reports to Jill. And in this case, it's Ben and Susan, right? So that's one particular way. Now, I may actually take the same org chart, all right, and model it slightly differently because my application uses that data differently, all right? And in this case, I may actually do the following. I may map a person and then an array of their directs. Okay, so if I start at the person level and then kind of want to drill into their directs, rather than from a bottom-up kind of approach, I start at the top and want to drill down, right? So now I can write the same kind of query. Well, the query looks slightly different because the data is different, but given person Jill, show me who works for Jill. In this case, it's Ben and Susan, right? And I can do, hey, given a person Bill or person Susan, who's their manager? In this case, it's Jill. So
now you're searching the array,
yeah,
which is the directs array.
Absolutely. So same questions I'm asking of my data, right? Same results I'm getting back of my data, but it's modeled slightly differently depending on my application's use.
Great.
Another quick one I want to take a look at is simple keyword matching. Right? So imagine a document modeled like this. This represents a course. So I'm doing some online course academy or university. All right? And I have a course called Fundamentals of Database Design. Now I want to go run a search that says, find me all courses where database is in the title. All right? It may be very easy for me to write a query that says, select from data where the title contains the word design. Right? And I'll get back a result. There it is, Fundamentals of Database Design, right? But it's a fairly expensive query, all right? Now, I might be able to kind of just make a few tweaks to my data model. And in this case, what I've done is I've added a keywords array, the words that I think people are going to search on. And I've run a little bit of logic in my application, all right, to lowercase and remove filler words and, tokenize each of the words. Now I have an array of keywords. And now I can run a slightly different looking query that still says, find me where the array keywords contains design, all right? I get back exactly the same result set, but at a much cheaper kind of cost from a query perspective.
All right. So now this isn't exactly a substitute for a search engine.
No,
right?
absolutely not. If you want to do like full text searching on massive paragraphs of text, there are better products for that. But if you want to do simple keyword kind of matching, this is a clever trick.
Fantastic. So another use case we have is telemetry. So what do I mean by telemetry? Maybe it's weather station data or IoT sensors, and these things are emitting data maybe once a second, once an hour, once a minute, right? We have connected cars, lots of different use cases. So you can imagine storing each of these readings in a single document. That's what we're showing now. So that's really easy to do. The only problem is there's a lot of overhead because you're storing the device name and you're storing a lot of extra data around it. Right now there's just the device ID, but maybe there's other metadata. So it could be the metadata is larger than the sample itself. So what you could do instead is aggregate data on maybe a time period. In this case, the example I'm showing is aggregated over an hour. I have 60 samples once per minute, and they're all stored within one document, so the metadata itself isn't repeated. I have the device name, maybe some device location, and other metadata, and then all the readings. So another similar use case is logging. Now logging kind of borrows from some of the other things we talked about. If you imagine you had a web server generating logs. So every time you have a log entry, you're emitting another document maybe. Now, we're back to the full text search type of challenge or the contains challenge. You probably don't want to actually store log data in its original form. Fortunately, with most logging, it's either fixed with or it's comma separated, so it's very easy to parse, and we can then store it into separate properties, which lets us do very simple searches. And think about how you want to partition log data, because log data could be pretty large. Maybe you partition on time period. Maybe it's the log type, events for warnings versus errors. Maybe it's different regions, but you get the idea. Right?
Cool. So, as a summary to kind of wrap up, we've seen that modeling data in a document database is still important. I hope you understand that modeling data